Topic of this video is the last chemical compound in this particular chapter, thiols. How do you name them, and what's an important reaction that they undergo? And naming them is the modification is you have the parent, so the longest continuous carbon chain, and then thiol. And then before X is the location of the thiol. And then the rest is naming the molecule like you would an alkane. So, an example: 1, 2, 3, 4, 5, 6, 7, 8, 9. So identify your substituents. Carbon number 7, got an ethyl group, 7 ethyl, and 9 is non-ane, but using that guideline, there's the thiol, the SH, or the sulfhydryl is sometimes what they're called too, if you see that. But thiol, this would be 2 non-ane, and then you add thiol to indicate that there's an SH group on the number 2 carbon. It's the parent. Then you merge the prefixes and the parent together, and this is 7 ethyl, 2 non-ane thiol. So very much a modification to how you would name alkanes with just thiol ending. One more for practice. Let's see. And then, it's a simpler one, but got 1, 2, 3, 4, 5. If I numbered it from left to right, it would be the same. 1, 2, 3. This is 3 pentane. You've got 5 thiol. So just treat the sulfur like you would the substituent. Now, reactions that sulfur-containing compounds undergo so 2 thiols, or 2 equivalents of the thiol, and you treat them with an oxidant, they will form what's called a disulfide. And that cross-link is called a disulfide bridge. And they're important for tertiary and quaternary protein structure. We've not gotten to proteins yet, but proteins are very complex biomolecules that perform a broad assortment of functions. They can be structural. Like keratin in your hair is a structural protein. Collagen in your joints, that's for you're connected to your skin, connective tissue. Actin, they're structural proteins. But you've got proteins that are enzymes that carry out vital biochemical reactions. But what often holds proteins together, their shape, their structure, are disulfide bridges. Okay? And also, disulfide bridges can be broken. H means reducing. We've seen O means oxidation. H means reducing conditions. To reform thiols. So this reaction is reversible. An important biomolecule that takes advantage of these types of reactions is glutathione. We'll draw its structure, but the business end of that molecule is a sulfhydryl, a thiol, an SH group. And glutathione is your most important antioxidant that you have pretty high levels, especially in your liver where a lot of detox reactions take place. And cycling between a reduced sulfur to a disulfide bridge, that cycling back and forth can protect or does protect you from some oxidation reactions that glutathione was being in trouble. Also, on a lesser note, straightening and curling hair is involved in breaking disulfide bridges, allowing them to twist around, and then reforming the disulfide bridge to make hair curly or to make curly hair straight, as far as a kind of application there. And that's the important reaction with thiols. They can be oxidized and reduced, cycled back and forth between oxidized and reduced states. And you name them very similar to an alkane, just you give the location of the thiol and then you modify the parent name to have a thiol